Hey, in this video we're going to concentrate on this man in the middle. He's walking on a moving sidewalk here in the opposite direction that the sidewalk moves. I'm going to pause that for a moment. I want you to concentrate on this person here. We'll assume that he stays in the same place relative to the observer or to the camera. As we run this, you'll see that there are people walking past him on the moving sidewalk. We can assume that the moving sidewalk moves at a constant velocity. All the people are moving at a constant velocity. This person, because he's staying in the same place, is moving at a constant velocity relative to the sidewalk at exactly the same speed, but the opposite direction that the moving sidewalk moves relative to the observer. Those two motions end canceling. Okay, so think about that. He's moving at a constant velocity, whether that constant velocity is a positive, negative value, or if it stays zero. Then that would still give us the idea that net forces are going to be equal to zero. Okay. Hey, so we'll go over and we'll take a look at the sheet that you'll fill out for each of these various scenarios. We'll come on back to this form and fill this out for the event that we're watching the man walking on the sidewalk. So I'll start doing that. So I've gone ahead and written a little scenario, and what's happening is the man walks at a constant velocity on a moving sidewalk at 2 meters per second. 2 meters per second is given to you in the problem. It wasn't in the video, but does not move compared to the camera. The man has a weight of 800 newtons. That's also given in the assignment. Okay. Hey, so relationship on this one, is he at rest? Kind of interesting. Would you say he's at rest or not? Relative to the camera, yes. Relative to the let's say relative to the camera or relative to the sidewalk, no. So that ends up making kind of an interesting question. I'll leave that up to you whether you think it should be yes or no. But in Newton's rule, that won't change it because he traveled at a constant velocity. Yes. Whether we're going to consider that 2 meters per second, or if we're going to consider that at 0 meters per second, both cases will be constant velocity. And are the forces balanced? Again, if we have constant velocity, the sum of our forces is going to be equal to 0, so yes, forces are balanced. For this problem, go ahead and put in your interaction diagram listing your non-contact and contact forces. Go ahead and complete that. This is incomplete, of course. Go ahead and make your force diagram. This again is also obviously incomplete. I need at least one other force because above we said it was balanced. I need at least some other force this way. I'll give you a bit of a hint there. Force normal on the mass from the moving sidewalk. Okay. Think about if there's forces left and right. Remember, they should be balanced in this case. Position and time graph. I'm going to, in my case, go back up here a moment. I'm going to consider that he is not moving relative to the camera, so I'm going to say that yes, he's at rest. Maybe a bit odd to think of it that way. That would end up him. If I end up putting a time in here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 seconds. 0, 1, 2, etc. It's going to be his position with respect to time. And his velocity, we'll have a velocity of 0 here. Those same times 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 seconds. My velocity is also going to be at 0 that entire time. There's no further question on this one. Hey, when you're done with this, go ahead and the hard copy you have of this, go ahead and take a picture of this, submit this through Schoology, then watch my solution to it. If you make any changes to that, go ahead and make those changes, resubmit that to Schoology. This marked up one, go ahead and turn in class. So just a little checklist here on what you'll be doing for each of these video assignments. 1, read the assignment, you'll have several of these over the next couple of days. 2, complete this form for the video. Go ahead and make the event, go over the parameters, your interaction and force diagram, and the position versus time, velocity versus time graphs. Make sure you label those as well. If there are any further questions, this one did not have any. If you have any further questions, go ahead and list that there. Okay. After you've completed that, go ahead and use either your device or your phone. Go ahead and take an image of that, submit that through Schoology. If you are using a phone, go ahead and submit that to your phone, to your device first, and then submit it to Schoology. Those will be a little bit cleaner. Okay, and then you go back and check that. Once you've submitted the assignment, you'll be able to check your answer on Schoology. That'll be the next item that comes up and is available to you. If after looking that, go ahead and revise and resubmit your assignment through Schoology. Hey, once you're happy with it, go ahead and turn the hard copy in class in one of the folders or bin that'll be in the front of the room. Okay, hey, good luck with this. They'll have several of these, maybe a new way to learn a few items here. So best of luck there.